processing, we can create processes, and we can run each process in parallel on a different CPU cores. So with multiprocessing, it's better for tasks that are CPU bound, where you need heavy CPU usage, whereas multithreading, that is better for I/O bound tasks where you do a lot of waiting around. So before we begin, I recommend these two imports, multiprocessing and time. Let's begin. Quick note, if you're running the Windows operating system, you'll probably need to add this line, if name is equal to main. So when we run a program, we have a main process that is running, and if we create a child process from that process, it's going to copy the module that we're currently working with, and that child process will create its own children processes, and it's going to be a problem. So we're going to add this line, if name is equal to main. So when we create a child process, it will copy our module, but it's not going to execute it. So let's create a main function, and a majority of our code is going to be within our main function. If you're running a different operating system, you probably don't have to do this, but if you're running Windows, you probably will. Now with multiprocessing is better for tasks or functions that are CPU bound, where they require heavy CPU usage. Let's say that we have a function named counter, and we'll pass in a number to count up to, but the number we're going to pass in is a ridiculously large number like a billion. So let's create a function that will count from 0. So count equals 0, and while count is less than our number that we pass in, we will increment our counter by 1. So that is the function that we'll call with our processes that we create. Now within our main function, we'll create a process, and to do that, you'll need the multiprocessing module. So import process and CPU count, and we'll save this for a little bit later. To create a process, let's say we have process A. A equals process. This step is very similar to creating a thread. We have a target. Our target will be our function of counter. And if we have arguments, we will pass those in. So remember, with our arguments, we have to pass in a tuple. Since we only have one argument to pass in, to differentiate this from an expression, we have to add a comma at the end. So our number, let's say, is 1 billion. So that's a million, 10 million, 100 million, 1 billion. Let me just verify that. Okay, so that's 1 billion. We're going to count from 0 to a billion. And in order to start this process, my process, use the start function. And then I will use some process synchronization by using the join function. My main process is going to wait around for my child process of A to finish before continuing. And let's print our performance counter. So we'll print finished in, let's say, time.performance counter seconds. Okay, so let's see how long it'll take to count from 0 to a billion using one process. I fast forwarded this video, but it took my program 56.7 seconds to count from 0 to a billion, but we can speed this up by using multiprocessing. Let's create a second process named B. And I'm going to divide the amount of work in half, so each process will count to 500 million, half of a billion. So let's change A to B, and I'm going to group these start functions together, just so it's easier to read, and then B.join, just to synchronize everything. Okay, and then let's change 1 billion to 500 million for each. It's the same amount of work, but divided among workers. So that is 500 million. Let's see how well it runs this time. So it took my program about 40.3 seconds to finish counting from 0 to a billion, but I divided that task among different processes. Each of my two processes counted from 0 to 500 million this time. So this time, let's create 4 processes. So we have A, B, C, and D. And we'll need to start them. And I'm going to join them. Now, this might not actually speed it up for you, and I'll explain why later. It depends on the amount of CPU cores that you have. Okay, so, let's change this too. So 250 million for each. Okay, see you in a couple seconds. Okay, welcome back. So on my computer, when I ran 4 processes and each was counting up to 250 million, I could finish my program in 27.3 seconds. Now, for me, if I created more processes than this, it would probably take longer, and here's why. So you can print the CPU count of your computer using this function of CPU count. So if I were to print whatever this function returns, I can get the count of the number of additional processes that I can run. For the time being, I'm just going to comment out this start function because I just want to print whatever this value is. So my CPU count on my computer is 4. So I can run 4 additional processes, but let's attempt to run 8 processes. So I'm going to copy all of these, and let's say that we have E, F, G, and H. And we will start all of those too. So give me a second just to start them. So A, B, C, D, E, F, G, H, and then I'm going to join all of them. E, F, G, and H. Okay, so let's run this now. Oh, and change the arguments too. I keep forgetting to do that. So let's say 125 for each. So 125 million times 8 is 1 billion. Okay, see you in a bit. Alright, welcome back. This time when I had 8 processes working, it actually took me longer than when I had 4 processes working. When I had 4 processes working, it took me about 27 seconds. This time it took 30 seconds when I had 8 processes working. That's because I had more processes than my CPU count. And that's partially because whenever you create a process, there's significant overhead with beginning and destroying a process. And if I can only run 4 processes on my computer at one time, well then I'm creating additional processes to no extra benefit. It's actually hindering the performance of the computer because I'm creating all of these additional processes when it really doesn't help me. In conclusion, multiprocessing is the concept of running tasks in parallel on different CPU cores. It's similar but different from multithreading because with multithreading, we can run tasks concurrently, but they're all taking turns because of the GIL. With multiprocessing, we can run all of these different tasks together in parallel. Multiprocessing is better for CPU-bound tasks, where a task has heavy CPU usage, and multithreading is better for IO-bound tasks, tasks that involve a lot of waiting around. So that's multiprocessing. If you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, that is how multiprocessing works in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video we're going to be creating our very first graphical user interface in Python, so sit back, relax, and enjoy the show. Welcome one and all. Today we'll be creating our very first graphical user interface in Python, also known as a GUI for short. We're going to be using the tkinter GUI, which is a module that is included with Python. Our first step in order to use tkinter is to import this module so that we can begin using it. Our first line of code will be from tkinter import asterisk. This will import everything related to the tkinter module. And with this import, we can now use all of the GUI features that this module has to offer. Now, there is one important distinction that we need to make. We need to discuss the differences between windows and widgets. Here's a few quick definitions that I definitely did not copy from the internet. Widgets are GUI elements such as buttons, text boxes, labels, images, you name it. And windows, they serve as a container to hold or contain these widgets. For this topic, we'll be creating and customizing our own window, and in future topics, we'll be exploring different widgets that are available to us. So let's begin by creating a simple window, and we should give our window a unique name, such as window. That's pretty creative, and in order to instantiate this window, we're going to follow this window name with equals tk. Make sure you get the capitalization right. This is a uppercase T, and a set of parentheses to serve as the constructor. What this will do, and I'm just going to add a comment, is instantiate an instance of a window for us. And when we compile and run this, nothing appears to happen. That's because we only instantiated our window and we're not actually displaying it. In order to display our window, we're going to follow this with the name of the window dot main loop, and this will display our window. And this is our first graphical user interface, and we'll be adding widgets to this window. So I'm going to add a comment that this will place window on computer screen, and it will also listen for events, but we'll get to that in future videos. Now what we'll be doing is customizing the appearance of this window. Let's begin by changing the size, and we can do that with the geometry function. So we're going to first begin by typing the name of our window, which is window, follow this by using the geometry function, and we pass in a width and a height, but make sure this is within quotes, and set this to whatever width and height that you want. So if I want 420 by 420, that would be 420 x 420. And the size of our window is now the size that we set with the geometry function. Now take a look at the top left of this window. We have this feather icon as well as a title of TK. That's kind of lame, so let's change that. Let's first change the window title, and there is a function to do that. So we type in the name of our window dot title function, and we can pass in a new title that we want to set. And I will set the title to be maybe Bro Code First GUI Program. That'll work. And we now changed the title of this window, and it says Bro Code First GUI Program. The next thing that we can do, although not necessary, is that we can change the icon of our window bar at the top. I would like to replace this feather icon with an image of my choosing. Here's my desktop, don't mind all of the clutter, and I would like to use this image of the logo for my channel and set this as the icon for my window. So what I'm going to do is copy this, and then go to my project folder, and then paste it. Click OK, and I now have this image within my project folder, but it's in a format that we cannot use currently. We need to convert this to what's called a photo image. That is a format that tkinter can use. So we'll need to convert our image to a photo image. So do that anywhere within the window between window equals tk and window.main loop. Right here is good, I suppose. We're going to create a photo image from this image, and this is a PNG file, but yours might be something different. So let's give our photo image a unique name, like maybe icon. And in order to create a photo image, we'll follow this with equals photo image. And within the constructor of our photo image, there's an option for file. We can either list the file name or the file path if it's somewhere else on your computer. Since this image is within my same project folder, I only have to list the file name. And this is called logo.png, and this is probably going to be named something else for you though. So we now have this photo image called icon that we can use. And I need to set the icon of my window to this icon. And luckily there is a function to take care of that for us. Type in the name of the window, which is window, dot, and we're going to use the icon photo function. There are two arguments. The first we're going to set to true. And the second is the photo image that we want to use, and this photo image is called icon. So we're going to pass this photo image as an argument to this function of icon photo. And now when we compile and run this, the image that we wanted to use is now set for the top left icon of this window bar. However, it loses a lot of the quality since the dimensions are so small, but you can still tell that it's my logo though. So that's how to replace the icon of your window bar in the top left corner. Now let's change the background color of this window, and one way in which we can do that is to use the config function. You can use the config function anytime that you want to make any changes to this window. So let's change the background color here, and there is an option called background, and we can set this equal to either a color name or a hexadecimal value. Let's begin with just some color names. Let's say that I want the background color to be black. I'll just type in the word black here, and this will change the background color of my window to black. Alternatively, you can set a hex value as the color. So if you were to look up or Google hex color picker, you can select whatever color you want. Let's say that I want a sky blue color like this. Well, this is the hex value. I'm going to copy this value and then paste it within the option for my background. Make sure you have this hashtag as well, because that represents that this is a hex value. So now the background color is that sky blue color that I picked. Well, everybody, that's the basics of creating a window in Python, and in future videos we're going to be exploring different widgets that we can add to this window that have some functionality. So if you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to create your very first GUI in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create labels in Python. So sit back, relax, and enjoy the show. What is a label? Well, I'm glad you asked that question. It's an area widget that holds text and/or an image within a window. So to begin, we'll need to create a window to act as a container to hold this label. We can create a window with window equals tk followed by window.mainLoop. And this will give us a window in which we can add a label to. Now let's give our label a unique name, such as label. And in order to instantiate a label, we'll follow this label name with equals label with a capital L and a set of parentheses. The parentheses are acting as the constructor for this widget, our label, and we can pass in arguments into these parentheses. The first argument that we're going to pass in is a master, the container for this label. We're going to pass in the name of our window because our window is acting as the container. With widgets in Python, we can delimitate the arguments that we're passing in with a comma, and there are options available to us. Options are keyword arguments that we can pass in to the constructor for this widget. One option available to us is text, and we can set the text of this label equal to a string that we set. So let's say that we want this label to say, hello world. Well, we're going to pass in this option, text, and it's a keyword argument. So if we were to do this, we're going to set the text of the label. But this label currently doesn't appear within our window. What gives, bro? I thought you knew how to code. Hold up, wait a minute. There's one more thing that we need to do. So we're going to actually add this label to the window now. We set the master of the label to be our window, but now we actually have to add it as step 2. One way in which we can do that is to use a pack function of our label. So follow label equals label and pass in all of your arguments, and then follow this with the name of the label dot pack. So with the pack option, by default, this will place our widget in the top center of our window. Another way in which we can add a label to a container or window is to use the place function, and we can set some coordinates of where we want this label or other widget to appear within the window. If we want this to appear in the top left corner, we can set x to equal 0 and y to equal 0, and these are options available to us too that we can pass in. So this place function will place our label at some position or some set of coordinates within the window. And with x equals 0 and y equals 0, that will place our widget in the top left corner of the window. And if I were to change these to, let's say, x equals 100 and y equals 100, well, this is going to be placed down by 100 pixels and to the right by 100 pixels. So you can use pack or place. There's a few others like grid, but they're a little more complex, so we'll get to that in a future video. For the time being, I'm going to use the pack function of the label and turn this place function into a comment, label.pack. All right, now how can we customize this label? We can pass in different options when we instantiate this label. Let's change the font, and that's another option. We can change the font with font equals, and then we can pass in a font. Let's begin with a font family. I will say maybe Arial, a size, perhaps 40, and then a style if you so choose, like bold. There's also italic and underline, but this will work just fine then. So this will change the font of the text of our label, and it says hello world still. Now let's change the foreground color. So that is another option. The foreground is the font color, and the option is FG for foreground. It's short for foreground. Foreground equals, we can state a color name such as green, and our text should now be green. You can select something more specific by passing in a hex value. So a custom color that I like is hashtag 00FF00. This is bright green. You can always look up what different hex values are. And we can also change the background color too. That is BG, short for background color. And we can pass in a color name or a hex value. I'm just going to set this to black, just to demonstrate that we can pass in both either hex values or color names. And what we have is green text on a black background. And this is the limits of our label within the window, because when we expand this window, the label is still going to stay the same size. If we were to change the text within the label, our label is only going to take up the room that it needs. And you can see that our label is now smaller. Now we have all of these arguments within our constructor, and it's getting a little bit difficult to actually read. So I'm going to separate each of these arguments line by line, just so that this is more organized, but it'll work just the same as it did before. Now, how do we add a border around our label? One, we can set the border style with the relief option, and one border that I like is raised. But right now, the border width is 1, so it's a little difficult for us to actually see the border. Let's increase the border width with the option BD, and I'll set this equal to maybe 10. So this border is now more visible. Another relief, which is the border style, is sunken, and this will give our label a sunken appearance, but I think I'll change this back to raised. We can also add some padding around the text, between the text and the border. We can pad X and pad Y. Pad X will add some padding, some space between the X-axis of our text between the border. So let's set this to maybe 20, and we now have 20 pixels worth of space between the text and the border. Let's also pad Y. This will add some space above and below our text, between the text and the border. Now, how do we add an image to a label? We first need to create what's called a photo image, and we will create this within the lines of window equals tk and window.main loop. And let's give this photo image a unique name, like photo. And in order to create a photo image, we're going to follow this with photo equals photo image. And within the constructor of our photo image, there's an option called file, and we can list a file path or a file name. Right now on my desktop, there is an image that I want to use, and I need to convert this to a photo image. Here's my desktop, and this is an image that I want to use to add to my label. I need to get the file path, and I can get that by going to Properties, then underneath Location, I can copy this location address and paste it within the quotes for file. And then I need to add the image name, and this is person.png. And with these backslashes, these need to be double backslashes because that is the escape character for a backslash. But what would be a better option is to add this image to my project folder that contains the Python file that I'm working with. So in place of listing the entire file path, I'm going to copy the image that I want to use, go to my project folder, and then paste it. And I no longer need this entire file path. I can just list the image name that I have. And now what we need to do is add this photo to the label, and there's an option to do so. That is the image option, and we'll place this within the constructor for the label. We're going to set image equal to the photo image that we have, and our photo image is called photo. This will add our photo image to our label, or other widget depending on what we're working with. So we have our image, but it replaced all of the text that we had for this label. How do we add both text and an image to a window? Well, we can follow this with the compound option. We can set a direction of where we want this image to be placed relative to the text that we have. So I'm going to set compound equal to bottom so that the image appears on the bottom or underneath our text. So we can both have text and an image. Or if I want this to be in a different location, I could set this to maybe top, left, or right. If I were to set this to top, we have our image on top of our text. And one thing to know about labels and many other widgets in Python is that the size of the widget will actually increase to accommodate the size of all the components that's contained within. If I were to give the text a longer string of characters, such as bro, do you even code, then the width of our label is actually going to expand to accommodate the size of the longer string of text that we have. So that's the basics of labels, everyone. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of labels in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create buttons in Python. So sit back, relax, and enjoy the show. Buttons. You click them, and then they do stuff. That's pretty much it. So this is how to create a button in Python. We'll need a window equals tk, followed by window.main loop. Let's call our button just button. And in order to create this, we'll follow this with equals button. And within the constructor for this button, we're going to list what we want to add this button to. What is the master? The master is the window. And in order to display this button, we're going to follow this with button.pack. And we should have a small rectangular button within our window, but it doesn't display any text, nor does it do anything. So let's add some text, and there is an option to do that. Within the constructor, we're going to list the option for text, and set this to whatever text you want to display. Let's say, click me, and then when we run this, our button now says the text that we set, and it says, click me. However, it currently doesn't do anything though. We need to set a command. That is another option. Command equals, and we list a function name. This is what's known as a callback. So let's create a function called click. And then outside of the window, let's define what our click function does. Def click, and let's print a message. You clicked the button. Now, with the command, we're going to list the function name without the parentheses. So make sure you're writing it as this and not that. This is what's known as a callback. So when we click on this button, it's going to perform our callback and perform whatever is within our function click. Just like that. Let's customize the appearance of this button. I'm going to change the font. That is another option. Font equals. And let's pick a professional font such as Comic Sans. It's very professional. And I'll set a size of 30. And now you can actually read what's on this button. It's large enough. Let's set the foreground color. That is the font color, FG. You can place a color name or a hex value here. I'll pick green, that is 00FF00. And our text should now be green, which it is. Let's also change the background color. That is BG. I will pick the color name of black. And now we have green text on a black background. Notice that when I click on this button or hold my mouse button down, the color scheme has changed. That's because there is a different active foreground and active background. And we can change those too, so that this won't flash every time you click on the button. So let's change the active foreground and active background. Those are other options, active foreground, and I'll set this to the same color as my foreground, which is green. So the text color is going to stay the same, and I'll also change the active background. And I will also set this to black to match my background. And then this should no longer flash when we click on our button. If you need to disable somebody from clicking on this button, there's an option to do so, and that option is the state option. And normally this is active, but you can set this to disabled, and we can no longer click on this button. And you can see that the color scheme has changed too. It's all grayed out and whatnot. So I'm going to replace this back with active because we still have a few more things to do. Now, how do we add an image to a button? There is an image option, and we set this equal to a photo image. But first, we need to create a photo image. I have this photo of a like button, a thumbs up that I want to use. I need to create a photo image from this image file. So within the window, let's call this photo image just photo. Photo equals photo image. Then I'm going to list the file path or the file name. Since this image is within my same project folder, I only have to list the file name, and this is called like.png, but if you use your own image, it's probably going to be named something else. Then I need to set the image equal to my photo image, which I named photo, but the photo replaces the text on this button, but it still works the same. So we would like to display some text as well as our image. We need to use the compound option, and we list a direction. We can list top, bottom, left, right. We want this image to be on the perhaps bottom, so let's list the bottom. And now when we run this, we have our text as well as our image. And if we changed compound to a different direction like top, then the image is going to be displayed on the top relative to the text. What if we wanted to count the amount of times that we clicked this button? We could create a variable called count, and we'll set this equal to 0. But in order for us to access this count variable within the function of click, we're going to list count as global, so that this is a global variable. Every time we click this button, let's increment our variable count by 1 by saying count plus equals 1, and then we will print whatever the value of count is. So within a print statement, we'll just say count. Now, when we click on this button, we have access to our count variable that's outside of this function, and every time we click on this button, it's going to increase our count variable by 1. Well, everybody, that's the basics of creating buttons in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of buttons in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a simple entry box in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, my fellow bros, in this video we're going to be discussing the entry widget. This is a text box that accepts a single line of user input. As always, we'll need a window. Window equals tk followed by window.main loop. And let's give our entry box a unique name. Let's call this entry for short. And then to create this entry widget, we're going to follow this with equals entry. And within the constructor, we have to state what we're adding this to. We're going to add this to our window, and we should finish this by packing it or placing it. Entry.pack. And we should have an entry box within our window. However, the text is somewhat small, so let's change that. We can set this as an option within the constructor of our entry box. So let's set the font. Font equals, and pick whatever font you want. I'm going to pick maybe Arial, and then a size, maybe 50. And this should be a little bit larger. And we can type in some text like this. Cool, right? Now, we should add a submit button, because right now this currently doesn't do anything if we type some text in. So let's create a button. I'm going to create this button maybe after the entry box. And let's say that this is a submit button. So let's call this submit button equals button. What are we adding this to? We're adding this to our window. And we'll set some text. Text equals submit. We'll also need a command for this button. Command equals, and we'll create a function called submit. And we want to pack this submit button to add it to the window. Submit button.pack. Alright, now let's put our entry box on the left-hand side and our submit button on the right-hand side. When you pack these widgets, you can set these on a certain side. Side equals left, and our submit button, we want this on the right. Not necessary, but I think it looks better. And we also need to define our submit function. Outside of the window, let's define what this does. def submit. What's this going to do? We need to get the current value that's within our entry box. One way in which we can do that is use the entry box's get function. This will return a string, and we can do something with that string, such as store this within a variable. So let's create a variable called maybe username. Let's pretend we're having a user submit their username to log into something, I suppose. So we'll get the current value of the entry box, store that within a variable, and we'll call this username. And then we will maybe print this for fun. Print hello plus user name. And let's try this. So here's our entry box here and our submit button. I'm just going to make up something, click submit, and it displays our message. Hello, I didn't say that this video was going to be professional. Let's add a few other buttons. Let's say we want a delete button as well as a backspace button. So let's copy what we have for our submit button and create a delete button and then a backspace button. The delete button's a little bit easier to code. So let's rename our submit button as delete button. Make sure to change the name too when you pack this. And the text, we will say delete, and we'll create a function called delete. And let's define what delete does. So after our submit function, let's define our delete function. And we need to delete all of the text within our entry box. One way in which we can do that is to type in the name of our entry box dot delete function. And this takes two positional arguments. Which portion of our entry box do we want to delete? So we want the very first character, that is index 0, followed by the last character, and we can say end. So this will delete all of the characters within our entry box, and let's try it. So I'm just going to type in my name, bro, I'm going to delete this, and all of the text is now gone. Just like that. Let's create a backspace button. We'll copy what we have for our delete button and change the word delete to backspace. Make sure you change that when you pack this as well. And for the text, we'll set this to backspace. And we'll create a function called backspace. And let's define what backspace does. So after our delete function, let's define backspace. And this is going to do something very similar to our delete function, except we're going to change the first positional argument. We need to place the second to last character within this positional argument. One way in which we can do that is to first get the entire length of all of the characters within our entry box. So let's begin by typing entry.get. And we need to determine the length of this, and we can surround this by placing this within the length function. So this will return the current length of all of the characters within our entry box, and then we're going to add -1, so that this first positional argument is the second to last character, and the second positional argument is the end, the last character. And then when we run this, let's type in our name. I'm just going to type in bro code this time. I'm going to click backspace, and then it's only going to delete the last character. And then if you were to click delete, it deletes everything. Broy. And then if you click submit, it's going to submit your name. All right, let's customize the appearance of this entry box. So within the constructor for this entry box, let's change maybe the color, maybe the background color and the foreground color. Let's begin with the foreground color. You can pass in a color name or a hex value. I want this to be green, so the hex value for that is 00FF00. And the foreground color of the text when we type it in is now green. And we can also change the background color. That is BG. We can pass in a color name or a hex value. I'm just going to say black to keep it simple. And we now have a black background, and the text color is now green. Here's a few useful features that you might be interested in. Let's insert some default text for our entry box. So we can use the insert function. Entry.insert. We place a positional argument as well as some text. So for the positional argument, let's say 0. So that's the very beginning, index 0. And let's set the text to maybe SpongeBob. And then the default text within our entry box is now SpongeBob. Another option available to us is that we can set the state of this entry box. We can set this to active or disabled. Let's say that after somebody submits our name, we want to disable this entry box. So we can either pass in this option within our constructor, or we can use the config function to make any changes to the state of our entry box. So let's say after we submit our username, we want to disable this entry box. So let's type in the name of our entry box, .config. And for the option for state, let's set this to disabled. And then once we type in a name and then click submit, our entry box is now disabled. There's also an option called show, where you can show a certain character in place of the normal text on the screen. So this would be useful for a password. Let's say that we're typing in a password, but we don't want to display the password on the screen. We can use the show option to show a certain character in place of our text. So you might see bullets or an asterisk. So let's pretend that we're now typing in a password. So we're going to set the option for show and place a character that we want to replace each character with. Let's say we want to only display asterisks when we type in some characters. And I'm going to type in the word password, but it's only displaying asterisks now. But if I were to click submit, it displays our text in, I would say, plain text instead of our hidden text, because we're only showing whatever character that we set. So that's an option available to you as well. Well, everybody, that's how to create an entry box in Python. You can submit information such as a username, for example, or even a password if you set the show option available to you. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's some of the uses of the entry widget in Python. Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create and customize our own check buttons in Python. So sit back, relax, and enjoy the show. Alright, my fellow bros, in this video we're going to be creating and customizing our own check buttons in Python. I sometimes refer to these as checkboxes, so in case I do, that's what I'm referring to. As always, we'll need a window. Window equals tk followed by window.main loop. And let's call this button just check button. And in order to create this check button, we type in the name of the check button equals check button. And within the constructor, what are we adding this check button to? We're adding this to our window. And also within the constructor, we can set the different options for how we want to customize this check button. Let's begin with the text. Text equals I agree to something. And last but not least, we need to add this check button to the window. One way in which we can do that is to use the pack function of this widget. So follow this with checkButton.pack. When we run this, we have our check button within our window, and we can toggle this on or off. Right now I'm agreeing to something. I'm not sure what I'm agreeing to, but hopefully it's not anything bad. Now currently this doesn't do anything, so we'll need to associate a variable with this check button. So we'll add that as an option. Variable equals, and let's create a variable called x, and we'll need to define this within the window. So after we create our instance of our window, let's say x equals, now with check buttons, they store a 1 or a 0 by default within our variable that we call x. So with x, we're going to set this equal to a int var. If this were to return a string, we would say string var, but normally by default, this returns a 1 or a 0. And we can actually change that using the on value and off value options. So the on value is what's going to be stored within our variable if it's toggled on. So by default, this is 1. And the off value is the opposite. This is what is stored within our variable if this is toggled off. All right, now let's have some fun with this. So let's associate a command with this check button. Command equals, and let's create a function called maybe display. And then let's define this before the window. Def display. And we're going to check the value of x to see if it's 1 or 0. So within our display function, we're going to check to see if x, and to get the value of x, we're going to use the get function. So if x.get is equal to 1, that means that somebody clicked on the checkbox or toggled it on. So if they check the checkbox or check the check button, then they agree. So print you agree. If it's 0, and we can do this with an else statement, else print you don't agree, frowny face. And let's test this theory. So we have our check button when we click on this, it's actually going to call our display function. I agree to something, and it says within our console window, you agree. And if I were to toggle this off, it says you don't agree. Let's change the font of our check button. So we'll add that as an option. Font equals, and we can pass in a font that we want. I'll say maybe Arial, and then a size of 20. And now this should be readable. I agree to something. Let's also color this because, well, I like coloring. Let's begin with the foreground color. So that is FG for short. FG equals, and then we can pass in a color name or a hex value. I like hex values, so I'm going to stick with those. I want a green foreground color, so that is 00FF00. But feel free to adjust these values however you want. So our text should now be green. That is a very bright green and it hurts my eyes. So I'm also going to change the background color, which is BG, and I'm going to set this to black. So we'll have green text on a black background. Okay, now when you click on this, it flashes. That's kind of annoying. That's the active foreground and active background. If we click on this or hold this down, the color scheme switches to our active foreground / background, and we can change those too. So I'm going to set those options. Active foreground. I'm going to set this the same as my foreground color. And the active background will be the same as our normal background. So that's active background equals black. And this should no longer flash when we click on it. Not too bad, not too bad. Let's add some padding. Pad X, I'll set this to 25. And pad Y, I'll set this to 10. We have a little more padding around our check button. One feature that's available to us is that we can add an image next to our check button. I downloaded an image of the Python logo that I want to add. So we'll use the image option to add a photo image to this check button. But first, we need to create a photo image from our image file. So within the window, let's call this Python photo, but you'll probably use something different for your project. Python photo equals photo image, and within the constructor for our photo image, we can set the file path or the file name. Since this image is within my project folder, I only have to list the file name, and this photo of mine is python.png. And now we set the image equal to our photo image that we have. Image equals Python photo, but when we run this, it's going to overlap the text. We still have our image though, and this still works as intended. So in order to display the image as well as the text, we're going to need to use the compound option, and let's add that at the end. Compound is where we're adding this photo relative to the text. I want this photo on the left-hand side of the text, so I'm going to set this to left. And now when we run this, surprise, surprise, our image is on the left-hand side. Something that you should know is that with the on value and the off value data type, if you were to change this to a non-integer value, let's say we're going to replace the on value with a Boolean value of true, and the off value is false. With this variable, make sure to change the data type as well to reflect what you're storing within it. So with our int var variable, we want to change this to a Boolean var value. So replace int with Boolean, and this will work much the same. Now with this display function, we'll need to account for that. So within the if statement here, we'll say if x.get. We don't need to say is equal to 1. This will return true or false, and this will work just the same as it did before. And if you replace this with a string, let's say the on value is yes, all caps, and the off value is no. This is now a string var, and we'll change our display function to say if x.get is equal to yes. And this should work. You agree, you don't agree, you agree, you don't agree. And I'll change that back to 1. So 1 and 0 is the default for this, but you can edit these based on what you need. Alright, so that's the basics of check buttons in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of check buttons in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to be teaching you guys how we can create radio buttons in Python. So sit back, relax, and enjoy the show. Okay, everybody, let's create some radio buttons. Now, these are similar to checkboxes, but you can only select one from any single grouping. So let's pretend that I'm buying you lunch, and you can only select one item from a menu. You can select either a slice of pizza, a hamburger, or a hot dog. So let's begin by creating a list. I will call this list food. Food equals pizza, hamburger, hot dog. And let's create a window. Window equals tk, followed by window.mainLoop. So to create a radio button, we'll need a name. So I'll call this radio button. Radio button equals radio button. And we're going to be adding this to our window. And we're going to put this within a for loop. So we're going to iterate through all of the items within our list. So let's create a for loop. So we'll say for index in range length of food. So this is going to iterate once through all of the elements within our list. So when we run this, it's going to create 3 radio buttons for us because we're instantiating one radio button for each item in the list. Now, what I'm going to do is set the text equal to our list of food at a certain index. So when we first run this for loop, it's going to be 0 for the index, then 1, and then 2, and then so on and so forth for each item within our list. And then we just need to pack this. So radio button dot pack. And then let's take a look at this. All right, so here are all of the radio buttons that we have. Currently, they're all selected though, so we'll need to link these within a single grouping. The next thing we'll add is a variable, and we'll set this equal to x, and we'll need to declare this after we create an instance of our window. So x equals int var. So this will hold an integer object. So these are all within the same grouping. However, if we try to run this again and select one of these options, they all become selected. So we're going to need to give each of these individual radio buttons their own value because right now they're all sharing the same value. So we can add value equals whatever the index is currently. So the first item within our list of food is going to have an index value of 0, then 1, then 2. So let's try that again. And you can see by default it's 0, so pizza is already selected. Then we can select either hamburger or hot dog, but we can only select one. So that's kind of what we want then. So do you guys usually know how I call the config function after each change that I make for an object? Well, that's because I like to add comments just for teaching purposes for what each change does. However, it might be easier for you instead of calling the config function a bunch of times, just to list all of the changes within the parentheses when you create an instance of the object that you're working with. However, just for teaching purposes, I'm going to put this all within separate lines. That allows me to add some comments. So I think I'm going to start doing that from now on. So what this does is that this adds text to radio buttons. And this groups radio buttons together if they share the same variable. So if you wanted a completely different grouping of radio buttons, you can give them a different variable like y. And what this line does is that this assigns each radio button a different value. All right, so let's make some cosmetic changes to our radio buttons. So right now, they are centered. Let's anchor these to the west. So we'll place this within the pack function. So anchor equals W. Alternatively, you can just say capital W without the quotes. This would also work too. So now they're all lined up. Let's add some padding. So I'm going to add pad X, and I'll set this to 25. And this adds padding on X axis. Let's also change the font. So we'll say font equals, maybe I'll pick impact for a font style, and set the font size to 50. And now we can actually read these because the font is large enough. Now let's add some images. So let's create some photo images. You'll want to be sure to create these after you create your instance of your window. So let's create a pizza image first. Pizza image equals photo image, file equals the file path or the file name, and my file is pizza.png, and it kind of looks like this. It's just the pizza emoji. So pizza.png. And then I'll do the same thing for hamburger and hot dog. So this will be hamburger image, file equals hamburger.png, and then hot dog image. And this is what the other emojis look like. And then let's create a list of the photo images that we have. I'll call this food images equals, then the names of these images, pizza image, hamburger image, and hot dog image. So then we can set the image for each radio button. Image equals the name of the list, food images, followed by the index that we're currently on within our for loop. So this adds image to radio button. And let's test this. Cool. Here's our images. Now, if you want some images as well as text, you'll have to use compound. So let's add that next. So I'm just going to add a comma followed by compound equals, let's say left. So this will add the image to the left of the text. Adds image and text. I'll just say left side. So this will display both an image and text. So with these radio buttons, you can eliminate these circle indicators, and there's actually a way to do that. So what we'll add, if you want to get rid of those, is indicator on equals 0. So this will, I should say, eliminate circle indicators. So it's going to change these to these push buttons. However, they are going to be of uneven size. You can set the width if you want to. So we'll do that. So we'll say width equals, what about 75? I'm not sure if that's a good size or not. Okay, that's way too small. Let's try 375. So yeah, you can have some push buttons if you want to, if you don't like the circle indicators. So this sets width of radio buttons. Now let's actually set a function to be called when we click one of these buttons. So let's call this function maybe order, like we're ordering one of these items. So def, we'll call this order, like we're ordering something. And what we'll do is just a few if statements because I'm feeling lazy. So we'll just say if x, that's the value that's going to be stored, because each of these radio buttons is grouped together by the variable x. If x dot get is equal to 0. That's our first index for pizza. What we'll display is print you ordered pizza. Then we'll just add else if x.get is equal to 1. We will print you ordered a hamburger. And then else if 2, you ordered a hot dog. Else print So there's probably a more efficient way to write this. However, I was just feeling lazy, and this is probably the best way to keep this simple and easy to understand. So let's try this now. Oh, however, we need to set the command for our radio buttons. So command equals then the function name, which is order. And make sure you do not add the parentheses. So don't do this, do that. And this will set command of radio button to function. All right, let's test this. So if we click on pizza, it says you ordered pizza, you ordered a hamburger, and you ordered a hot dog. Okay, everybody, so that's the basics of radio buttons. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of radio buttons in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a sliding scale in Python. So sit back, relax, and enjoy the show. Let's create a